Hi dear students. Let's see this question that was asked in JEE Advanced Paper 2 Physics in the year 2020. This was a multiple choice correct question, and I am sure that almost more than a lakh students in India would have done this question correctly. For no reason whatsoever you can get this question wrong. A fairly simple question, like one of the most regular questions that you can ever get. Very easy picking. So let's see what's happening over here. A rod of mass m is hinged about its top point. A particle of same mass strikes the rod at a distance x below the top point, and the particle sticks after collision. We have to find the angular velocity acquired by the system after collision as a function of x. The particle is striking at distance x below the top end. We also need to find the value of x such that the angular velocity becomes maximum, and we have to find that maximum angular velocity as well. I will tell you, this is a very simple question, but I will still tell you one amazing thing, that how we could have minimized the calculation in this. So let's see. Suppose this is a rod and this is hinged at its top point O. So the particle strikes the rod at a distance of x below the top point with velocity v. So we can conserve the angular momentum about the top point. So this will give us mvx, which was the initial angular momentum of the particle about point O. Rod did not have any angular momentum. After the collision, the system will have moment of inertia as ml square by 3 plus mx square. This is the moment of inertia of the rod plus this is the moment of inertia of the particle into omega. So this gives us omega as m will cancel out, you can see over here. So what do we get? Vx upon L square by 3 plus x square, right? Now one way to find the value of x such that omega becomes maximum is simply we can differentiate this d omega by dx and apply the division rule of differentiation, and we can solve this. But if we are slightly careful, then we can minimize our calculation like anything. We can divide this whole by x, so this will become L square by 3x plus x. Now if we want to if we want omega to be maximum, then this needs to be minimum. So if you instead of, this is a constant value, so instead of differentiating the whole function, if you just look at the denominator, so this is L square by 3x plus x, and if you differentiate this, so what do you get? This becomes L square by 3x square negative, right? And this is 1. Sorry, this is 1. So this should be 0, right? So from here we can say that x becomes L by root 3. You can see how easy it has become, or how simple calculation has become. X becomes L by root 3 since it cannot be negative. So when you put this value back over here, or we can directly put over here in this function. So omega maximum will become, this is x maximum, omega maximum will become v into L upon root 3 divided by L square by 3 plus x square, which is again L square by 3. So what do we get? This is 2L square, 3 will go up. So this will become root 3 V by 2L. So let's go back to the options. If you take 3 LCM over here, so this will become 3Vx upon L square plus x square. 3x square, sorry. So option A will match, which is in fact the correct answer. Then xm is L by root 3, which we have found out. This is the correct answer. Sorry. And omega m is root 3 v by 12. So which of course is this. So I hope you would have understood and you would have enjoyed this solution. That's all. Thank you.